Yeah. So hello everyone. I'm introduced this resource paper, OpenSiteRec and Open Dataset for site recommendation. So this work is done mainly by during my visiting at Nanyang Technological University, and this work is also supported by the City University of Hong Kong and Huawei. So let's start with the preliminary sets to introduce what set recommendation task is. So actually, selecting an optimal set to open a new branch is really crucial for the development of a brand in modern businesses. So, however, this complex task is mainly accomplished by professional employees so far, so which is labor-intensive, time-consuming, and will introduce human bias. That's why we need to do an automatic site recommendation. So set recommendation aims to recommend the optimal locations to the open branch stores for a given brand by considering the existing branch stores. However, there is no public available data set, and most existing approaches about the set recommendations are really limited to an extremely small scope of the brands. So let's see the related works. This picture shows all the related works of set recommendation, and we could see that our OpenSiteRec dataset has many superiorities over all these related works. The first thing is that wide range and large scale. Our dataset is much larger than all the related works, and also we will include some rich commercial features which are not included in our other works. And also, we are comprehensive information in our dataset, and most importantly, our dataset is public available. It's the first one in set recommendations. So the overall schema of this set recommendation dataset is just shows on this figure, and we have the brands, the regions, and actually the POS serves as a bridge between the brands and the regions. And also for the POS, we have the commercial features, which are the categories, and also some competitive or related brands. And for the geographical features, we have the business area, which is a combinations of some regions, and we also have the nearby or similar regions of it. For the data statistics, we could see we have millions of geographical units, and there are also thousands of POIs and the regions and the sites, and also the brands. So for the sets distribution, it's really interesting. You could see that for these four metropolis, for example, in New York City, all these sets are actually in several regions rather than across the whole cities. And the data example is shown also in this figure. We have the general features, we have the commercial features, and also geographical features. And for the category distribution, we can see some interesting things that different cities, the people in different cities will have different lifestyles. For example, the people in Chicago, they will think they will have more sports POIs, which think maybe those people in Chicago are more like to do some sports. But in Tokyo, the transportations POIs are much more than all other cities, which thinks the Tokyo peoples they will more like to do some going outside or something like that. And also the transportations are much better than other cities. So we also do the benchmark experiments. We test some widely used baseline models on our dataset, and we could see that machine learning models are really easy to overfit, and different models all converge to the same local point. So that's maybe the dataset features that this dataset is extremely sparse. So you need to do some things to make it to get a good result. And finally, our dataset actually could support other potential applications in urban computing, such as brand entry forecasting. That's which brand will have the highest potentials to lead to a business succeed in other cities. And also it will support the business area planning for the governments. So that's all for this work. If you are interested, welcome to the poster session tomorrow. Yeah, thank you.